Добрый день, уважаемые участники. Слышно ли меня?
Да, слышно.
Мгм. Do we have English speakers here?
Yes, I speak English.
Okay, okay. Because of some technical problems, we will start right now. The first talk is algorithm of finding all maximal induced big list of hypergraph. Alexander Soldatenko and Daria Semyonova. Are you ready?
Yes, of course. One moment, please.
Yes. As you know, the talk should take 15 minutes, but it's better if it takes, I think, 12 minutes and we have 2-3 minutes for questions.
My screen is. You see
Yes, it's
the
working.
presentation? Good. Good. I suppose it's afternoon already. My name is Alexander Soldatenko, and topic of my talk is algorithm of finding all maximum induced by clicks of hypergraph. Nowadays, hypergraph are actively used in modeling road and telecommunication networks, as well as for constructing semantic networks when processing text in natural language. In this work, we are research problem of finding all maximum induced byclicks of hypergraphs. So, maximal induced byclicks are used in telecommunication networks for extraction, subnets, and routing purposes. Moreover, byclicks can be used for modeling point to multipoint and multipoint to multipoint connections and services with more than two entities. Besides telecommunication networks, we are needed in a road network for pre-processing in database for clustering and by-clustering. And at this frame, you can see definitions necessary for further presentation. These include definition of hypergraph, subhypergraph induced by the set of vertices, bipartite subhypergraph, and vertex graph of a hypergraph. Let us illustrate these definitions. So at the figure 1, hypergraph is shown. Vertex graph L sub 2 of hypergraphs H is presented at figure 2, and agency matrix of the vertex graph is shown at figure 3. Last figure is represented by bipartite subhypergraph with first parts what contains the vertices 1 and 4, and second part what contains vertex 3. The algorithm proposed in this study used in its work the statement of theorem 1. The theorem says about the correspondence of the bipartite subhypergraph and subgraph of vertex graph, which is shown at figures 5 and 6. Definitions of byclick and maximum induced byclick are given as this frame as well. So maximum induced byclicks generations problem is as follows. Let the hypergraph H without double hyper H is given. It is necessary to find the set of all maximum induced byclicks. Also close to this problem are the problems of finding all maximally complete submatrices of binary matrix and finding all concepts of the context. Not that all of these problems are at least NP hard, and problem of finding all concepts is sharp P. So curse of dimensionality takes place. It is known what bipartite hypergraphs can be written in the form of the binary matrix of the vertex graph. Moreover, such a matrix will have form 1. Obviously, for complete bipartite hypergraphs, the submatrices B prime will be complete. That is, they consist only of ones. Algorithm for generation maximum induced clicks requires that both sets of vertices and sets of hyper H of hypergraph H are lexicographic ordered. Agency matrix of vertex graph is represented as hypergraph phi. If matrix of sub-hypergraph phi prime satisfied to form 1 from previous frame, then phi prime is called induced biclick. The set of all induced biclicks where first part size is equal 1 is equal L is called the L layer of the hypergraph phi. The main idea of algorithm consists in generation of all induced biclicks for all L layers and filter from them maximum induced biclicks. Propose that find MIB algorithm solves this problem in 3 phases. Let's demonstrate this in the diagram. On initialization phase, the transition from input graph H to vertex graph L sub 2 is occurred. On generation phase, for agency matrix of vertex graph represented as hypergraph phi, all L layers are generated. On filtration phase, for all generated L layers, all maximum induced biclicks are selected. This grants all maximum induced biclicks for hypergraphs. Time complexity of affine MIB algorithm is shown at this frame. Note what time complexity of the affine MIB algorithm depends on size of the set MBC, which can exponentially depends on the size of the hypergraph. The delta value corresponds to the maximum vertex degree in hypergraph. However, this estimate is overestimated since a biclick of size delta delta exists only bipartite hypergraph as stated at lemma 1. Algorithm was tested on generated hypergraphs with various vertex degree delta. Results are presented in the table 1. Execution time of hashfind MIB algorithm essentially depends on cardinality of the set MBC. However, it has a reasonable execution time for these hypergraphs. So in this paper has been investigating the problem of finding all the maximum induced biclicks of a network represented by a graph or hypergraph. A new algorithm for finding all the maximum induced biclicks is presented. We can highlight the following promising area for research. First, improving performance and clarification, the complexity of proposed algorithm for graph and hypergraphs of special type. And the structure of affine MIB algorithm assumes the possibility of using parallel computing technology to speed up its works. That's all. Thank you for your attention.
Okay, thank you. I think that your timing is too much perfect. But so, do we have some questions or comments or something else? Okay, I have one little question. Could you please tell us the sizes, the number of vertices of graphs you used? Because I think if the graph is quite big, this algorithm will take too much time. And the second little question is for which sizes of graphs this algorithm was developed? Big graphs, or small graphs, or some special types?
We developed this algorithm for special types. This algorithm could work perfectly for graph with small size of degree value or delta value. So it's perfect when it's 5 or 6 and experiments we test this algorithm on hypergraphs with size of sets of vertices equal 100 and 500, but it's only in this paper. So And with time complexity, you can see it's exponential algorithm, but it's a problem with no, it is numerical problem in the end.
Okay, thank you. Do we have any further questions or comments? I think there is no questions. So thank you for your speak, and we should go to the second one.
Thank you.
The second speaker is Alena Borisovskaya. The talk is Linux Network Device Drivers, NAPI polling in kernel threads.
Good afternoon, dear participants of the conference. So, can you see the presentation?
Yes.
Okay. My name is Borisovskaya Alena. I'm graduate student at Russian University of Transport. And let me present you my work about Linux network device drivers, especially about NAPI polling in kernel threads. In this work, we discuss basic concepts of implementing NAPI compliant drivers and also about new features in 5.12 kernel. Linux networking subsystem is modeled on the BSD stack. Data reception and transmission are at the transport and network layers occurs with the socket interface. But unlike Unix sockets, the TCP/IP sockets use the network protocol for operation. When created by syssocket system call, it takes parameters for domain, name, local and remote IP addresses. Socket buffer is actually a packet, and it's a link list of these structures is the network interface queue, receive and transmit queue. The function of network drivers is to implement the link layer and providing the interface between kernel system calls and a network card. Processing of incoming and outgoing packets is performed using the XMIT and RX functions. They are protected from concurrent access by spin locks. Operation of updating statistics and changing transmission parameters are also protected by spin locks. The interface itself is defined by the net device structure. Alloc netdev and register netdev functions are called to create and register a network device. Network device driver is similar to block device driver. It transmits and receives data on demand. But block drivers only respond to kernel requests, and network drivers receive packets from the outside asynchronously. For a long time, Linux had hardware interrupt handling mechanism when a network device asked to put incoming packets into the kernel. But prior to 2.3 kernels, after calling the top half of interrupt handler, the bottom half and task queue were used to perform main tasks. But in later versions, bottom half interface has been replaced with the software interrupt handler or software queue. The advantages of software queue are that they can run concurrently on different processors. They are also used in for networking purposes. As long as the network traffic was low, the interrupt mechanism for receiving packets successfully coped with this work. But while traffic was increasing, the interrupt handling led to a shortage of processor time for user programs and packet loss. A solution to the problem was suggested in 2001, and it was a new AP. The main purpose of NAPI is to reduce the number of interrupts generated while receiving packets. NAPI combines the interrupt mechanism with the polling mechanism. Most often the use of polling is avoided because resources can be wasted when the device don't receive any packets. But high-load interfaces don't have this problem. So NAPI compiler drivers disable interrupts when the packet arrives at the interface. The interrupt handler calls the RX schedule to ensure that the packet processing can be done later. But when the incoming packets are through the buffer, the limit is in variable budget. It calls the def poll method for further processing. Poll method will be called concurrently on many processors, so the synchronization made easier. Polling method also can be used for packet transmission, and now the transferring a packet is implemented in transfer NetTX SoftIRQ. But when implementing NAPI compiler driver, must be several requirements must be met. First one is ability to store incoming packets in direct memory access ring or in a network card buffer itself. The second one is the ability to disable interrupts. Then in the poll method should be able to process several packets at a time. Since the poll method works in the context of SoftIRQ, and you need to change the polling priority to balance resources between the interrupt handler and user programs. But NUAP has some disadvantages. There are, in some cases, there may be delays in the system because of the calling def poll method. IRQ masking can be slow, and it may occur in some cases IRQ race condition. But in a series of patches in the latest versions of Linux Scanner, the poll method was moved from SoftIRQ context to a kernel thread. The reason for this decision was the inability to track software interrupts in system. A scheduler can't measure the time it takes to process the SoftIRQ, but the kernel thread, on the other hand, is visible for CPU task scheduler, so this will avoid overloading the processor on which it works and make scheduling process more deterministic, and it's made easier synchronization. Also, the changes mainly affected the file netcore def, and NAPI poll method is now called from CAFRET context. But to enable thread support after creating a K-thread, you need to call NAPI set threaded, NAPI state threaded flag. Due to addition of the threading, there is also a new method, NAPI thread wait. Summing up, we can see that the polling method effectively copes with the problem of reducing the number of interrupts from network devices. Also, NAPI provides a function poll in the context of software interrupt handler, but since SoftIQ has a number of disadvantages, and NAPI compiler drivers are very difficult to manage. In the latest versions of kernel, poll method was moved to context of kernel thread. So one kernel thread runs one on each CPU, and that makes the synchronization easier. Thank you for your attention.
Okay, thank you. The second talk also have a perfect timing, and we have time for questions and comments and something like that. Do we have some questions? Okay, I have one simple question. During your talk, I don't understand what exactly you do inside this work. Could you please tell us?
Yes, my plans is to make magister work on the term of network device drivers. So, firstly, it was only the first step when my purpose was to research information about the network device drivers. So the next step is to develop a virtual interface and to generate traffic and to emulate high loaded interface. So it would be done in server work.
Okay, thank you. And one more question from me. And what is the main application of your work in traffic?
The application is to reduce the traffic on high-loaded interfaces because many server network cards have the hardware mechanisms to manage high load traffic, but for example, in ordinary network cards in user computers where we haven't got this hardware mechanism. So I think it's possible to use some software mechanisms to reduce the maybe a packet loss on the user systems. I think I would experiment with some generated traffic and some virtual interface on user computer.
Okay, thank you once again, and maybe we have some other questions. I think we don't, so thank you for perfect timing, and see you soon.
Thank you.
Okay, the next talk is a method for link quality estimation in LoRa network based on support vector machine. Who is the speaker? I can't hear you.
Sorry. Hello, everyone. Dear colleagues, and good afternoon. Can you see my presentations?
Yes, perfectly.
Okay, my name is Vandai. Currently, I am working as a PhD student at the Bond Privilege, St. Petersburg State University of Telecommunications. Today it's my pleasure to present our research on link quality estimation in LoRa network. So the talk will be based on the following structure, from the overview of basic link estimation methods to proposed LoRa quality estimation methods. As we know, the long-range network or LoRa networks has attracted much attention since its emergence, especially many applications many IoT applications have been developed based on the LoRa network. The communication range can be active over hundreds of meters to transmit sensor data. However, the transmission over long distance in different environments, like in urban environment with different building densities, may be difficult to have reliable packet reception rate. Therefore, an approach of LoRa mesh network has been investigated. In the LoRa network in particular, or in the wireless sensor network in general, the selection of routing paths is always challenging due to the link's dynamic behavior. The link quality must be suitable for critical industrial application, as they require sensor data to accurately measure the environment and communicate with other nodes without error. A link quality estimation is considered as a process to estimate the reliable level of connection between nodes. So the high quality links ensures the network quality of service in decreasing the packet loss. The link quality estimation can access higher network protocols to mitigate and overcome the less reliable links. For instance, link quality estimation is an assistant for routing protocols to maintain the routing paths, maintain routing tasks, and moreover, link quality estimation can also assist to maintain the network topology. So in this work, we propose a method to estimate the link quality in the LoRa network. There are some basic link estimation methods which can be implemented based on the hardware and software implementation. The first methods can be implemented based on the received signal strength indicator, or RSSI. RSSI is an estimated measure of power strength that an RF device receives from another RF device. At long transmission distances, the signal gets weaker, leading to the probability of packet losses, since the receiver cannot decode the signal correctly. The signal is measured by the receiver signal strength indicator, which in the most case indicates how well a particular radio link can hear the remote wireless node. For example, in here we have an example of using RSSI to estimate the link quality in the Wi-Fi network. Another metric is signal-to-noise ratio, which defines the level of received signal to the level of background noise. The less noise is generated by the receiver, the better signal-to-noise ratio. The graph here shows the change of S and R from -10 to 10 decibel in the LoRa networks, as know that the LoRa technologies has a high reception sensitivity. Similarly to RSSI, link quality indicator defined by radio chip manufacturer is an integer value used to estimate the link quality. Link quality indicator is usually used to quickly determine whether the link belongs to reliable reception range or not. For example, this indicator is implemented in some transceiver in ZigBee network to estimate the link cost. After receiving each packet, the link quality indicator resolves as an integer ranging from 0 to 255. The minimum and maximum link quality indicator values correspond to the lowest and highest quality signals detectable by the receiver. Based on the hardware implementation, we can estimate link quality based on RSSI, link quality indicator, and all signal noise ratio without additional calculation from the wireless transceiver. However, this value can be only obtained from successfully received packets. In this case, a packet loss, the link quality might be overestimated. Moreover, the measurement results are very unstable. Hence, it's difficult to estimate exact link quality if not only measurement is performed. Despite fast and cheap implementation in the hardware, these methods allows obtaining limited information about quality links for stable channel. Thus, using a combination of hardware and software metrics will improve the accuracy of link quality estimation. The software implementation allows to estimate some values such as the packet reception rate or packet delivery ratio, throughput, expected transmission number. In a certain transmission period, packet reception rate can be obtained by either direct calculation or approximation. Therefore, a term of the window size is considered to choose an interval time to calculate packet reception rate. As a result, an accurate estimate can be obtained in the short term with high or low link quality. On the other hand, a larger window size is required to obtain packet reception more accurately. Another method consider a number expected transmission as a metric for link quality estimation. That means how many transmissions are required to transmit the packet successfully while considering the number of lost packets. So in here we proposed a link quality estimation method which is considered as a process of evaluating the link quality based on metric within a certain estimation window. The estimation window can be interval time in the second or a number of received packets. To have data for link quality estimation is required to monitoring and measure data. Then the link quality estimation model processes the received data to give a link quality score. In this case, we propose a link quality estimation based on support vector machine, which is one of the famous popular machine learning techniques to classify data. The data set used for channeling is obtained from the practical experiment. We use two LoRa nodes in the experiment measurement, including a sending node and a sink node. The sink node is fixed and connected to a computer to save the experimental data. On the other hand, sending node moves far away from the sink node at low speed to measure signal power and noise changes related to packet reception rate. After this experiment, we receive 2,500 packets for further processing. In here, we can see the graph presentation of RSSI and signal to noise ratio, and here we choose 10 window size equal to 10 receive packets to calculate the average of receive RSSI and receive SNR according to the packet reception rate. Based on the data analysis, we expect to use the average of RSSI and SNR values that could help us to estimate the link quality level. Approximately from this range, we can have 4 levels that we expect to consider the link quality. The link quality estimation is converted to the multi-class classification problem, which can be solved using supervised learning models. And support vector machine is known as one of the efficient supervised learning models for solving multi-class classification. This slide presents the OSVM structure using 3 parameters.
You have 2 minutes left.
Okay. The dataset was divided into 10% for training and 19% for testing. We performed 50 training time to receive the mean accuracy, the proposed model. In here, we have data flow to pre-processing and training the model. According to the evaluation results, the SVM model presents a high prediction accuracy with the mean equal to 95%. Thus, using 3 parameters such as RSSI, SNR, and packet reception rate, the LoRa link quality can be estimated accurately up to 10 proof packets, even though our dataset size is not large enough for training, as usually can be seen in machine learning problems. So in this research, we considered a method for estimating the LoRa link quality. The link quality estimation is developed by based on some metrics, and the estimation problem was converted to a multi-class classification, which can be solved by using support vector machine. And despite using small data sets for training a number of probe packets, the proposed model has shown a high prediction accuracy. So thank you for the attention.
Thank you for your good timing. We're also on time, and I think we have 1 minute for questions. Do we have some questions or comments? Okay, no questions and comments. I have one little question. You showed the experimental data inside your work.
Yeah.
I didn't catch what exactly this experiment showed for us. Could you please explain shortly?
Yes, shortly experiment you transmission between 2 nodes. We so distance between 2 nodes is different, and we measure packet losses from between nodes, and according to the received packet, we measure also RSSI of received packet and SNR signal to noise of received packet received packets. So based on this data, we can estimate how well is link received and how bad is link received.
Okay, thank you. Do we have another questions? I think no. So thank you for your talk. And here we go. Yes. Here we go to the next talk, which is analysis of network security issues in the joint procedure of LoRaWAN. And who is
Thank
the
you
speaker?
for the introduction. I shared the screen. Can you see it?
Yes, perfectly.
Okay, perfectly. Thank you. My name is Legend, and it is my pleasure to present our research concern at DCCN 2021. So today I would like to talk about the network security issues in the joint procedure of LoRaWAN. Here is the outline. It's quite much, but don't worry. I will summarize the things and make it short. We will talk about security issues, a little bit about joint procedure, and we will analyze the jamming attacks, replay attacks, and we suggest a possible attack scenario. I will talk a little bit about the existing solutions at the end of this presentation. So here I want to show you a statistic about the number of LP1 connection by technology worldwide from 2017 to 2023. And there are 4 leading LP1 technologies. You can see LoRa, Sigfox, and the IoT, LTE-M, and etc. And the portion of LoRa, you can see here, it becomes more significant. According to the LoRa Alliance, LoRaWAN deployments are now present in 142 countries, and this statistics answer the question why we care about the LoRaWAN. And here is another statistic. It is IoT attack volume trend by quarter. In September 2020, IBM Forbes reported that IoT attacks from October 2019 through June 2020 rose 400% when compared to the combined number of IoT attacks in the previous 2 years. So we were talking about the reason why we care about the LoRaWAN in the first statistic. And here in the second statistic, it is why we focus on security issues in LoRaWAN. So on this slide, you can see a table describing briefly some security threats in LoRaWAN. These threats impact on the end device, or sometimes it impact on anti-LoRaWAN. For example, for joint packets, it impacts on anti-LoRaWAN, and it is one of the major risks in LoRaWAN. Here are some common type of attack: man in the middle, DOS and DDoS attack. Other attacks are carried out at the physical layer, for example, destroy or remove a device cloning, or RF jamming. RF jamming is a critical and major risk for LoRaWAN. It impacts on entire of LoRaWAN. We will talk about a little bit about the replay attack later. And here we also see routing attacks, rogue gateway attacks, etc. However, take a look at the architecture of the LoRaWAN. So in LoRaWAN, we have 3 communications. The first one is communication between the end node and network server. The second one is communication between the servers, network server and application server. And the third one is the communication between the application server and the user. The network server is responsible for validating the net access of the end device in the network. And the application server ensures that the network operator does not have access to the end user data. But you can see here the second communication and the third communication, they are used other types of networks such as LTE, Ethernet, etc. So consideration of security issues in this process are not related to LoRa technology. Therefore, we only focus on analyzing the security issues of the communication between the end device and network server. And here is coming joint procedure. So what is joint procedure? And when a new LoRa end device is added to LoRa network, it should go through an activation process. Currently, LoRa provides two types of activation methods. The first one is activation by personalization, or ABP, and the second one is over-the-air activation, OTAA, which is called joy procedure, and you can see that on the slide. Of course, we don't have time to talk more detail about the joy procedure. We only need to remember that in joy procedure, the end device sends a joy request message to the network server with some parameters. And network server will check that message. If the message is valid, the authentication will be conducted. And then it will generate a network session key and an application session key. The application session key then will be transferred to the application server so that it will ensure the secure of communication between the end-to-end or between the end device and application server. The end device, when receive the message, a joy accept message from the network server, will extract the information, authenticate it, and will generate network session key. So end device and network server will use network session key to exchange the information between them. That's all. That's all about the joy procedure. However, the joy procedure faces some critical attacks. The first one is jamming attack, as I said before. The jamming attack, like a denial of service or DOS attack on the wireless channels. Its purpose is to interfere with the access between the end device and network server by emitting a noise signal in the vicinity of the LoRa end device. So we have two types of jamming attacks. The first one is trigger jamming, and the second one is selective jamming. Trigger jamming is easy to carry out because it triggers a noise signal and impact on the device working at a specific frequency. However, it is also easy to be detected. And we have the second one is selective jamming. Selective jamming only interferes with device or message that have been selected before. So it's highly effective, but it takes long time because the attacker needs to capture the packet and analyze the packet, extract the information, and make a fake device, etc. That is about the jamming attack. Of course, we cannot steal any information from the jamming attacks. And here, a comparison of trigger jamming and selective jamming techniques on about the advantage, disadvantage, etc. How to deploy them. Let's go on. And here, the second attack I want to show you. This is the replay attack, and it relies on characteristics of up-node parameter or down-node parameter. An attacker may change the message between the end device and network capture. For example, on this figure, you can see that the message from the end device can be captured and modified, and then the attacker sends that modified message to the network server so that he can imply the malicious message. Even in some case, he can spread the malware to the network server. So it is a critical, attack in this LoRaWAN network. So I want to note that although selective jamming attacks are difficult to be detected and their success rate is quite high, the consequences just stop at the level of interference or destruction of the network operation, rather than stealing information or spreading the malware in the network. But the replay attack can do that. However, the replay attack have a low success rate. So here in this slide, we suggest a possible attack scenario where we combine the replay attack and the jamming attack, selective jamming attacks. Here you can see that an attacker can have two devices. The first one is a device to make the selective jamming, and the second device is a replay attack device. In the selective jamming device, they have three modules. The first one is the signal capturing module. This module will capture the packet from the end device to network server, and then that packet will be processed at the processing packet. In this module, the packet will be extracted. The important parameters, the important information will be extracted. And if the packet from this capturing is from the selected device, the jumper module will be triggered, and it triggers a noise signal to prevent the join request message from the end device to network server. At the same time, the information extracted from the packet can be sent to the signal receiving module at the replay device via wire links or via LTE, etc. At replay attack device, the attacker will generate a fake join request message, and that join request message will be sent to the network server. By doing that, network server will communicate with the fake device, and the attacker can exchange some malicious message. This is the combination of selecting jamming and replay attack, but is used for the join request message. For the new version of LoRaWAN of LoRa technology, this scenario may not work well because the join request message is encrypted. So, but the logic of this attack scenario can be used for the new version of LoRa, because we can capture the packet from network server, send back to the end device. It means the accept request message. So that is the reason why I want to show you the combination of these attack. And here I want to talk a little bit about the existing solution. We can see that there are some solutions, for example, creating density LoRa networks with overlapping coverage regions, optimizing the channel hopping usage, analyzing the transmission rate,
2 minutes
etc.
left.
Yes, sure. Thank you. And those solutions have advantage and disadvantage. They sometimes can prevent the jamming attacks, sometimes prevent the replay attacks, and maybe they can prevent the combined attacks. But please remember that there is no solution for all the attacks, and it leaves room for our future research. That's all. That's what I want to show you today. Thank you for the listening, and I'm waiting for the question or recommendation from you. Thank you.
Okay, thank you for your good timing. And do we have some questions or comments for the talk?
Actually, I want to share a little bit. We want to do some experiment with this scenario.
I'm
but
sorry, I
due
have
to the...
one question.
Oh, yes, sure.
Okay, the question is follows: what is the main results of the work? Because I don't understand, and I don't have a special slide with results, so I can't understand what is the main result. Could you please tell us?
Okay, of course. The main result is analyze the attack scenarios that can be can be carried out in the LoRaWAN, because we care about the security. We don't want to be stealed information. We don't want to have a network server which cannot work when a DOS attack is coming. So we analyze, and we talk about the jamming attack, replay attacks for the joint procedure, because joint procedure is what we care about. And we suggest a attack scenario where the attacker they combine those type of attacks. That's all. That's what we want to show. And as I said, that I want to do some experiment with this scenario, but we don't have equipment because due to the coronavirus situation. So we're looking forward to do that.
Okay, thank you. Thank you for the talk.
Thank you.
The next one is the next talk is customer experience model for customer digital twin. Are the speakers here?
Yes, I'm here. Do you hear me?
Yes.
Can you see my presentation?
Yes, it's
Yes,
okay.
perfectly.
Great. Dear colleagues, at first, um, let me thank organizers for this important event, for the possibility to meet you all, and for the possibility to discuss here together our ideas. And my presentation is about digital twin idea and about how to build it uh, together with customer experience model. So digital transformation today is associated with transition of cyber physical systems through the use of digital twin technologies, the industrial internet, big data, artificial intelligence, machine learning, and so on, etc. And digital twins are being developed for industrial enterprise, engineering, manufacturing, and operations, and for maintenance and service. The technology of digital twins is being supported. Such technologies like industry 4 as Internet of Things, artificial reality, product cycle management, and so on. And the main reasons and value of industries are it is a collection and use of data in real time that makes it possible to increase the accuracy of modeling and reduce the error of discrepancy with a real object. The the ability the ability to integrate vast data sets into a single model of a particular value. Digital twin bring the greatest effect during implementation, starting from the early stages, such as the design and engineering process, then covering control system production and economic data, the stage of model adaptation during operation, and the emphasis is on predictive analytics and what-if simulation. Uh, Realizing this, we can think of digital twin for some communication service provider. Today, the digital twin can be useful for a certain range of problems of the operations, administrations, and maintenance class of tasks, which could be solved by the digital twins more accurately and dynamically together with already known traditional approaches. Requirements for a high response rate of control system and high control dynamics follow from the current situation and forecasts for the future. We see rapidly growing density of devices, rebuilding their network topology, Internet of Everything, 5G, 6G, etc. From one hand, the operations operations, administrations, and maintenance tasks of digital service provider can be formulated in terms of traditional abbreviation. Uh, FCAPS means
I'm
the key.
sorry. I'm sorry. Do
Yes.
somebody? I see only the first slide. Is it okay or no?
Oh, sorry. Yeah, I'm sorry. Yeah.
Okay. Okay. Thank you.
Um, too much tasks at the same time. Yeah. So we on this slide, uh, on the slide we have some dimensions of applications for digital twin of digital service provider. So, for example, analysis of extremely rare events when the knowledge base or large operating company is formed for the case of events that are difficult to predict and difficult to analyze. For example, a meteorite crash or something like that. The second one is modeling of difficult formalizable and difficult predictable results. Another case could be improving service level and reliability through preventive or predictive maintenance. Preventive maintenance helps you act proactively to reduce the number of problems that may arise. And so on, you can see them on the slide. The slide 4. Uh, uh, sorry. The idea of digital twin came from these two main ideas. The first one is intelligent enterprise management paradigm, and the second one is DSPAR, the signal as a single operating system for some company, for entire company. The idea is the second one says about some kind of mirror of the big enterprise or company or anything else like that, um, to uh, to resolve those problems I just told you about on the previous slide. So to solving this problem, we decided to find the decision to build the kind of digital twin. Everything is in the beginning now, so I will try to explain the main idea. The information system domain model by Professor Sotnikov is used as a basic model. You can see it on the slide. Domain model makes possible to identify info communication system components, define the inter-component interfaces, and consider the information interaction processes within the model. There are 3 domains within the domain model associated with 3 relatively independent but closer linked types of activity. The physical domain on the left side is mostly concerned with energy processes and the interaction of material objects. The simulation, analysis, and intellectual activity producing evaluations and solutions is the product of mental and physical activity of the cognitive domain on the right side of this slide. The information domain is the idea for the circulation of data used by the cognitive domain, representing the objects and the processes from the physical domain. The perception of physical reality represented by information entities is linked with information interaction and occurs on the border of information domain and cognitive domain. The next slides 5, 6, and 7 give the formal mathematical definitions used here in our article, in our speech. Here there are, it's information is information is sent, information is perceived, information impact, information exchange, information interaction, And I think it is not necessary now to discuss these slides, these 3 slides. This term were discussed during previous conferences, and I'm giving them here just to show that there is strong definitions of all processes and interactions in the frame of suggested domain model. Yes, and as for these 2 slides with a lot of formulas, they describe an elementary interaction between 2 information systems within the information domain: transmission, reception of the representation of the physical domain in information domain. This slide show the shared information and data model by telemanagement forum. And it was needed to build our new cross-domain model, and I will try to explain the idea. Considerable number of target management models have already been developed. For example, this one within the NGOS frameworks concept, and among these models, the above described domain model proposed for describing the processes and transferring information for source to receiver and info communication system as very well studied as a basis for building a specialized model for managing info communications. So in already known domain model, we need to make some additions which will reflect a focus of our digital twin on telecommunications. We used already developed concept frameworks by TM Forum, which is currently dominant and de facto standard in automation of telecommunications. Also, the ideas of frameworks has some shortcomings which currently don't allow building a digital twin on this basis. So, for example, we can't use this shared information and data model directly to build the digital twin. So, but we have found that this model includes needed for us horizontal domains, and they reflect all the info communication, let's say communication focus. For example,
2 minutes left.
10 minutes, 2 minutes, just a moment.
2 minutes. 2 minutes.
Okay. I will try to be a bit more fast. Or so we have built so-called cross-domain model, which uses the standard shared and information data, and we build it based on domain model. And now we have our new cross-domain model, which is includes all the positive moments of those 2 models. It consists of vertical domains and horizontal areas. And physical domain includes operator, physical infrastructure, services, customers who CSP interacts with, other entities of the physical world, objects necessary for realization of the business goals and of the communication service provider. We have information Domain includes all sorts of data and information about physical objects. You can see here on the slide. It can be OSS and BSS systems, middleware, different software bases, smart agents, and so on. Um, Let me go through some slides because we have not so much time. So as a sources for our digital twin is different systems, OSS and BSS. You can see them here as an example. So uh, we can build a customer digital twin or infrastructure digital twin. So this task, this speech is about customer digital twin. Uh, to build it, we used uh, customer life cycle stages from TM Forum standard documents. Here you can see the such life cycle stages, and we tried to use we used the second one named by to build our model based on fuzzy cognitive maps. So our model is consists of 3 levels. The first level uh, includes customer experience
I'm
metrics.
sorry, but the time is over. So maybe you go to the conclusion and said that just the main results.
Okay, the main results is we have built the model cognitive fuzzy cognitive map for to use it in our um, digital twin for as a part of say big digital twin of customer of communication service provider. We have built mathematical model and we now have already built and we tried it this model, this cognitive map for accessing and the integrated customer experience of the whole stage for customer. Now you can see it, and I would say that this is just beginning. This is the first model of customer for digital twin, and we are going to build such maps for other different levels and stages of customer experience life cycle. So this is, I would say, this is almost all I wanted to say. Sorry for so long speech.
Okay. So thank you for the talk. Maybe we have some short questions or comments.
Yes.
Okay. I have one question. You said a lot about physical domain and information domain, and there is a connection between physical domain and information domain. But as far as I understand, we have a lot of physical processes, but on information domain, we have some information, not the whole information, just some information about some processes, not the whole processes, just some processes. And this information sometimes has errors, sometimes it's not complete, and so on. So the question is, where do you get the information that uh, that the information is enough for analysis, or this information is not enough and the decision making will be not so good as we expected?
Okay, I'll try to answer a question. Thanks for that. At first, um, uh, we have a lot of already working in IT landscapes of operators systems such as customer experience, kind of, I don't know, CRM and so on and so on. If some information we could take from these systems, some information we cannot, and in this case, and this is a reason why we use fuzzy models. We use just approximate numbers. We use okay. Sometimes we can't say that we know everything, and in this case we have to use some fuzzy algorithms to find okay, let's say kind of approximate decision of some task. I'm not sure I'm answering your question, but maybe
Okay, thank you. I think we can discuss it further because we don't have enough time right now.
Okay.
Once again, thank you for your talk. It was interesting for me, and I think we should go to the next one.
Thank you. Thank you.
Yes. Oleg Boychenko is here, or someone from the previous talk, evaluation of the quality and optimization functioning information systems. Somebody here? If not, we go to the next talk, integrity, resilience and security of 5G transport networks based on SDN and FV technologies. Someone here? Speaker is here. I think that for this talk, we also don't have speakers. Okay. We already have one talk, which from a previous day, from yesterday, which is identification of narrowband wireless communication network systems and Internet of Things devices using blockchain technology.
Yeah, hi. So I'm here. My name is Albina Pomagalova, and now I'm ready to start. So give me just 1 second, please.
Yes.
Okay. So please tell me, can you see my screen?
Yes.
So, okay. And now I'm ready to start. Thank you so much for the opportunity to tell our work. So we are very sorry for some delay. There were some technical mistakes. So in this case, we have to talk about it today. Thank you for your time. So let me start now. My name is Albin Pomagalova, and I'd like to present you our work identification of narrowband wireless communication network systems and devices of the Internet of Things using blockchain technology. So, and let me start from some introduction to this problem. So, and all of us, we know that the growth of various devices and sensors of the Internet of Things, the necessity of their organized interaction and accounting is a topical and long-term problem since the beginning of the development of the Internet of Things as a concept. So thus, until a few years ago, the number of such sensors and devices was in the thousands, whereas today it's about millions and billions, as you know. Besides sourcing devices of Internet of Things and debugging their interaction, one of the key problems remains identification of such devices. So we think that identification of Internet of Things device is a main problem for today's day. The International Telecommunication Union has formulated common requirements for an identification system that would address a number of existing problems. So our research concluded that the DOA, Digital Object Architecture, was suitable for such a problem. The handle identifiers used in the DOA architecture are unique and consistent in the global namespace, guaranteeing the resolution of the digital object to the valid information when the client requests it. But as we know, the security of such identification system is a big problem also, and we have two problems: the identification of Internet of Things devices, and the second one is the security of this identification and other stuff that we got after this identification system. However, in addition to distributed administration, it's required to add the ability to establish a chain of changes in a digital entity at all stages of its life cycle. So in this case, we thought that using blockchain technology is the best way to try to fix this problem with the security and with remaining one line of chain of information in one line. In this case, the main goal of our work is to study the possibility of interaction of the architecture of digital objects with a blockchain network to control changes in the identification system. So, and to achieve this goal, we have some research. Also, we set up model stand to check our experiments and perform a number of experiments. So before also we review some related works. So we had to know if there were some other experiments in this year, and maybe there are some other decisions how to fix this problem of security and changes in the chain. And the research we carried out within the framework of the proposed concept showed that today there are particularly no such experiments with selected identification system. But there were some works devoted to research the possibility of combining the Internet of Things sphere and blockchain technology, but there is no work with experiments with DOA system and blockchain. In this case, we started from the main stuff and the main part of this work with blockchain network setuping. The main components of our blockchain system is proof of work consensus algorithm. Sure, we know this is quite old for such work because it's much better to use proof of stake or maybe proof of elapsed time consensus algorithms, but we decided to start from some more convenient and more easy to set up consensus algorithm, and just in case to ensure Z-tag of 51%. So we decided to use guest clients because it's very easy to set up it because we work with this client and it's pretty functional. So guest client is the Ethereum network prototype and it's quite easy to set it up and to use. So we have quite many utilities and some special tools we can use. Also, we got some smart contracts written on Solidity language because it's main language of Ethereum network, and as the main file of our ecosystem, blockchain ecosystem, is Genesis JSON file, which we set up with our special components and special settings, and we use it to make 3 virtual machines with 3 nodes with mining function. So we need mining function, as you know, just to make some blocks, provide some blocks, and write transactions inside of these blocks. And this transaction has some information from the DOA system. That was the main idea of our experiment. So here you may see our model stand architecture that we developed, and the model bench device interaction is shown on the slide. So let me start from the right side. Here is our blockchain system. As you can see, there are 3 nodes, guess Ethereum node 1, 2, and 3. They are synchronized and work in one ecosystem. And then we got our Web3.js and Ethereum API just to interact with it. We're using HTTP server. Also, we have REST API stuff from the client at REST API, which work with the main client and with our blockchain system, and also REST API stuff just to handle system REST API and LCS database. So as you can see, we have a LCS database that can talk with client and also talk with our blockchain system. As we can see, when we just try to get the identification, we can ask with REST API for the stuff from LCS system, and at this moment we have some recordings to LCS database and also at the same time to blockchain system. So also LCS database can just look for the information from blockchain system just to synchronize information and be sure that the identification number is not doubled and it's really one in the system. So, okay, let's go next to the research script. And as a part of the research, the authors evaluated the possibility of interaction between the blockchain network and the identification system of narrowband wireless communication devices and systems. The DOA digital object architecture has been chosen as the most efficient and effective system for identification of narrowband wireless devices. The handle system was chosen as an implementation of the DOA concept, as you can see. The key object of the study is to assess the feasibility of validating all processes in the identification system using blockchain technology, in particular to log all changes in the descriptor. And now I'd like to show the first our picture, creation a new handle system descriptor to save two blockchains. So now we just write information and write it inside to the blockchain ecosystem. So this figure presents a sequential query schema for the system when adding a new descriptor and storing data in blockchain. As you can see, we have some stuff that goes through handle system REST API and then gets to blockchain and then back to the client. Here you may see our request and response. So in the reply and response, we can see the saved descriptor and the blockchain transaction ID. So the next one is retrieving data from handle system descriptor. And here is sequential schema of system calls when the handle ID descriptor is resolved into meta information on a digital object and receiving data from the blockchain network. In this case, a common chain is formed from the network, which is then additionally filtered on the client according to the necessary handle ID. So the final part of my presentation is our results, which we got from our 50 tests conducted to measure response time of LCS API service. And the first one is LCS API response time when creating a descriptor as well as writing to a blockchain. So as we can see, it's quite fast, but there are some problems when we have quite a big stuff to write to the blockchain system, and we have a little bit more time we need to write to the blockchain system. So the next one is resolution time of the descriptor as well as capture of the chain from a blockchain in milliseconds. So as you can see, it's quite stable on a 60 milliseconds, but also we may try to make it a little bit faster. And the last one, time of chain extraction from blockchain. So as we can see, it's also quite fast, but we can do some stuff just to make it a little bit faster. As a result of our work, we can say that we need just to restruct our blockchain system. We need to make it a little bit faster. We can do it using our Genesis JSON file just to make some settings and to make a little bit faster making the main blog. But if you're talking about security, it's better to make difficulty in the system a little bit higher. So, but we do this difficulty higher, our miners should work a little bit faster and a little bit more long, and time of writing and conducting data from blockchain system will be a little bit higher. So from the creation time schedule, it can be seen that the creation of a descriptor in LCS and then the subsequent synchronous recording of data in the chain can be as high as 60 seconds. So and now we decided just to change our blockchain system from Ethereum and Gas to maybe Tron or other with proof of stake consensus algorithm just to make it a little bit faster. So also we are looking through Solana blockchain system to make some private network using their consensus algorithm and their some settings and clients. And then we try to make this blockchain system a little bit faster. But if we're talking about security data, it's quite a good way to securely store data from LCS and synchronize them. So that's all. Thank you for your attention. And now I'm ready to answer all your questions.
Okay, thank you for the good timing. Do we have some questions or comments, maybe? Silence. Okay, maybe I have one question. I saw a lot of works about the security inside some digital systems, but as far as you know, we don't need security only inside digital systems. We also have some security things just for people, because you can have a very good system, but if the user tells his password for everybody, this security mean nothing. What could you say about this?
Oh, thank you so much for question. You know, it's really actual because sometimes it's really difficult to work with the client stuff. And in this case, we were thinking about using a private key, but do not let client see the full private key information. So the only one way to fix this problem now is to take some data from client's computer without his actual work with a full private key. Only one way we can do this without giving a full private key to the client. But nowadays we can, I think that we can't have any idea how to fix this problem from the client stuff. Only one way is to use his private key without notification. So you know that the client does not know where is private key stored on his computer, for example. But if this person will give his or her computer to anybody else, so our system will be also broken, as we can say. And I think that we will work in this sphere also, but now we have no answer for this question, because it's very actual.
Okay, thank you. Thanks a lot. Maybe we have some another questions or comments or something like that. Okay, thank you once again for your talk. Okay, fortunately or unfortunately, we have just finished this section. Thank you everybody for the talks, and thank you everybody for answering the questions. Okay, I think that's all. Ну и по-русски всем спасибо, кто выступал, спасибо, что подготовились, спасибо, что пришли, спасибо, что послушали друг друга, задали вопросы.
Спасибо, всего хорошего.
Спасибо, до свидания.